Chemical kinetics deals with rate of reaction, factors influencing on rate of the reaction, and the mechanism of the reaction. Depending upon rate, the chemical equations are classified into three types. That is, very fast reactions. For the completion of these reactions, few seconds are required, very less time is required. That is, when NaCl react with AgNO3, it gives AgCl. Here ions mutual exchange taking place. From NaCl, Cl minus ion is added to the Cl Ag plus ion, then we get AgCl. It is mutual interchange of ions, and it is all ionic reactions are very fast reactions. And barium chloride, when react with H2SO4, barium sulfate is obtained. In this compound, barium plus 2 ion added to sulfate ion. In this compound, cation is bonded by sulfate ion from H2SO4. It is the ionic reactions. And let us see the reaction if 3Fe plus 3 when react with Sn plus 2, it gives Sn plus 3 and Fe plus 2. Here we observe the Sn plus 2 is converted to Sn plus 3 and Fe plus 3 converted to Fe plus 2. So here the electrons are transfer from one compound to another compound. It is plus 3 to plus 2. Decreasing oxidation state indicates reduction reaction, and reduction reaction indicates gain of electron, and it is the oxidation reaction indicates loss of electrons. It is not a very fast reaction. All ionic reactions without electron transfer. In this reaction, electron transferred from oxidation to reduction, whereas in this compound there is no electron transfer, just mutual exchange of ions takes place. It is the very fast reactions. So all ionic reactions without electron transfer, they are comes under very fast reactions. And the next one, very slow reactions. For the completion of these reactions, very long time period is required. Very long time period means a carbon react with a carbon oxygen producing carbon dioxide. So it is the very slow reactions. It is very slow reaction. And third one is moderate reaction. Moderate reaction. For the completion of these reactions, few minutes are required. That is decomposition of H2O2 to H2 and O2, and next for dissociation of N2O5 to NO2 plus half O2. It is the classification of reactions depending upon the rate. Next subtopic is rate of the reaction. Rate of the reaction is a change in concentration in unit time. So when the reaction A gives rise to B, initial at T is equal to 0, A cannot converted into B. At time 10 seconds, some compound of A is converted to B. At this time concentration of A is X and concentration of B is 0. After some time X is decreasing, X minus A, initial concentration of A is X. After some time its concentration decreasing and that decreasing is converted to B. The decreasing is A. At a time T, the B formed is A. It indicates when the reaction is proceeding, so concentration of A decreases and concentration of B increasing takes place. That is the rate of the reaction, change in concentration in unit time. This can be written as rate is equal to change in concentration by time. If it is the reactant, decreasing concentration of the reactant by time. If it is the product, it indicates increasing concentration of product by time. So it is the rate of reaction. So we can go for the graph representation. So it is the x-axis and it is y-axis. On y-axis we can take time. Here concentrations are taken. Let us see, initial value is 0, 1, 2, 3, 4, 5 on the values on x-axis, 1, 2, 3 on 4 on y-axis. Reactant concentration from 4 and it is the decreasing graph. And when the product is increasing, so initial concentration of the product is 0. After some times it increasing occurs, that's why it is the concentration of a product increasing terms. And here the concentration of reactant is decreasing, it indicates the curve represents the reactant concentration. So then rate is equal to decreasing concentration of reactant by time and increasing concentration of product by time. So it is the initial time T1 and it is the final time T2. Change in concentration indicates concentration of the reactant at time T2 minus concentration of reactant at time T1. It indicates concentration of reactant R at T2 minus concentration of reactant at T1 divided by change in time. So here it is the higher value and it is the lower value. When we subtract from higher value minus lower value, this value is plus. But here we can take it is as minus. It represents this minus represents the decreasing concentration, and product concentration is plus. Product concentration at time T1 minus product concentration at time T2 divided by change in time. In chemical kinetics, the term minus dr by dt indicates change in concentration of the reactant with respect to time, but this negative charge indicates decreasing concentration of the reactant. It is represented as a rate of consumption. Rate of consumption or rate of disappear. And whereas plus dP by dt indicates product concentration changing time. Here plus indicates the increasing concentration of the product with respect to time. It is rate of formation or rate of appearance. These two terms are used to rate equation and rate expression. Various types of rates of reaction. Rate of reaction represent as dx by dt. Here x is the concentration and t is the time. It may be represented as dm by dt. Here m is the molar concentration and it may be represented as dm by dt or dn by dt into V. It is the molar concentration, and for molar concentration m is equal to number of moles per liter volume V. That's why we can replace m value with n by V. And it may be represented as 1 by V d by dt of weight by molecular weight. It is in terms of weights rate expression. It is in terms of moles rate expression. It is in terms of m molar concentration rate expressions, and where the rate expression may be represented as dx by dt. Here x is the maybe molar concentration or number of moles or weight. And from PV is equal to nRT, here the n by V is equal to P by RT. This equation n by V we can write in the place of n by V, that is P by RT. Then rate equation may be represented as dP by dt into 1 by RT. Here these terms are used for the rate expressions. Rate expression in terms of molar concentration, in terms of mole, in terms of weight, or in terms of pressure. In this expression, the units for rate expression is mole and time inverse. Molar time inverse. It is mole per time, mole time inverse, and it is pressure time inverse. Pressure time inverse. Here both the values are weights, and it is the gram per time inverse or kg time inverse. These are the rate expressions in terms of various rate expression of the reaction. Ma plus Nb gives rise to Pc plus Qd. Here you observe these two terms are reactant and these two terms are products. So in the chemical equation, the reactant concentration will decreases and the product concentration is increases. For this equation, rate expression dx by dt is its concentration is decreasing, that indicates negative, and dA by dt is the rate expression. Coefficients are taken as their reciprocal. Here m is the A coefficient and its reciprocal is 1 by m. That is equal to decreasing concentration of B, and decreasing value is minus. That concentration may be represented as dB by dt, and their coefficients in reciprocal, it indicates minus 1 by n into dB by dt. And these two are products and their concentration increasing indicates plus change in concentration dC by dt, and their coefficients taken as reciprocal, it indicates plus 1 by P into dC by dt. And next for D, it is also in the product side, its value increasing, then this coefficient represented as the reciprocal and rate represented as d by dt. It is the rate expression for a equation. Rate expression for the reaction N2 plus 3H2 gives rise to 2NH3. It is dx by dt in terms of concentration minus dN2 by dt. It is the reactant and their coefficient is 1. It is also a reactant, coefficient is 1 by 3 minus dH2 by dt, that is equal to 1 by 2 into product formation takes place plus 1 by 2 into dNH3 by dt. It is the concentration terms in terms of concentrations, and we can write in terms of moles, that is minus d number of moles of N2 by dt. This value is negative reactant concentration, and it is for NH2 1 by 3 into minus change in number of moles of H2 by dt. For a ammonia product formation taking place, that's why its value is positive, and change in number of moles of ammonia by dt. And this expression in terms of partial pressure, that is change in partial pressure of N2 by dt, that is equal to minus 1 by 3 into change in partial pressure of H2 by dt, that is equal to plus 1 by 2 into change in partial pressure of ammonia, that is d partial pressure of NH3 by dt. And you want to write the rate expression in terms of weight, that is dW by dt. Here the ammonia value is atomic weight 28 grams, that is 1 by 28 into d weight of N2 by dt. And with respect to hydrogen, its atomic weight is 1 by 2 into coefficient value 1 by 3 minus weight of hydrogen by dt. With respect to ammonia, their weight is 1 by 17 into coefficient 1 by 2 into weight of NH3 by dt. Let us observe these equations. There is a similarity in terms of concentration, in terms of number of moles, and in terms of partial pressure, their rate expressions. Whereas with weights, these values are multiplied by their atomic weights and molecular weights reciprocal. That's why rate equation is applicable for when the expression is rate equation is expressed in concentration, number of moles, and partial pressure. For the writing of rate equation in terms of atomic weights, we have to multiply the molecular weight of that compound in reciprocal.